clicker?
I'll bring it to you in a second.
Thank you very much. Well, that's quite something to live up to, so I hope I'm able to enlighten you all if you haven't heard of the computing continuum. So I'd like to start with something that may be slightly provocative for all of you, which is, there you go, if I can get this to work. The clicker doesn't seem to be working. There we go. So first statement, IoT is dead. Long live IoT. And what do I mean by this? Essentially, that we've moved from an environment in which we were just talking about individual sensors into something much more complex. We're looking at systems of systems that involve devices at the edge. We are talking about nodes at the edge, but also on-prem. We're talking about cloud, and we're not talking about different levels of connectivity throughout the whole of this. And a key to this is the ability to adjust to the needs of the different domains into which these technologies are going to be deployed. So what is a computing continuum? First of all, it is heterogeneous. We're talking about different types of devices, but also different types of computing resources. We need to collect and distribute data and also analyze that data at very different points of that continuum. And we need to make sure that we are doing as much as we can close to the edge. Our first panel was really focusing on the environmental impact and the social impact of new advanced technologies. Well, making sure that we're doing as much as we can at the edge means that we're able to save energy and save on computing resource, and that, of course, collectively and on an aggregate level will mean that we have a more or less of an impact on the environment and energy consumption. The two final things that I want to highlight about the computing continuum is the ability to act autonomously. And we'll be seeing that increasingly, not just in environments, for example, for self-driving vehicles, but also in factory settings where robots are becoming more and more autonomous, and the role of the factory operator is going to be more of a co-pilot, so human-in-the-loop environments in which humans can oversee the roles and the actions of robots and really be able to focus on what humans do best. The final thing here is different latency needs. So if you're deploying in environments, for example, agriculture environments, you will not necessarily have to have super high latency. If you're looking, again, at the environment in which you're looking at autonomous vehicles, so self-driving cars, every split second is going to make a difference and have an impact on, for example, safety, but also being able to navigate, to getting from A to B as quickly as you possibly can. So, complexity. If we look at the 1950s, a car maybe had a car engine, had maybe a couple of hundred parts at most. Modern cars have 10 to 20 times that amount. And increasingly, those parts involve sensorization. So the sensors can be in anything from pressure to telemetry systems, but also sensors attached to the pilot. So sensors that are going to be able to communicate with a living human being within the car and tell, in the case of racing cars, for example, tell the cockpit exactly how they need to kind of suggest the driving style perhaps needs to be modified to win the race. So it's never been so simple, but it's also never been so complex. If we look at the IoT reference framework, and this is from ITU in 2012, it's relatively simple. Most of you will recognize this, and in fact, we can probably transpose this on some of the slides that we saw earlier. I think Liliane had something where you could probably pretty much pick it up and place it on top of this. And it's nice and simple. Every person understands what the different components are and how they relate to each other. The work that we've been doing is really around meta-operating systems that are much, much more complex. So we're not just talking about the big containers or the big, middleware, firmware, levels, but also about different components within that. So microservices, whole layers around cybersecurity, cluster controllers. So much, much more complex, but also underlying all of this are new technologies that are making it simpler for people to gain the skills to operate within any of these systems. It still means that you need to have people who understand the system and system as a whole, but within any one of these, there are new AI-enabled from prompt engineering, if you can call prompt engineering really engineering, but you can have a whole load of new systems and tools that will help you deploy and design and check any one of these components. So this is all well and good, but this is a very technical view of what the computing continuum and the new IoT frameworks might look like. So how does the market see it? This is, you can probably see this, hopefully you can see it better from where you're sitting, but we did a survey with IDC as part of some work that we were performing, something called Unlock. We're looking at the different Meta OS operating system use cases, and we asked users and deployers in industry, around 800 of them, how much they were spending in each of these three areas, so cloud, edge, and IoT, and what their predictions were. And you can see that the spending, as a proportion, the spending on edge is still far smaller than the spending on cloud computing or on IoT. But the room for growth, or the compound annual growth rate, is predicted to be the highest in cloud, with a healthy 20% year on year, and the edge also 14%, and IoT 10%. So healthy growth rate, but perhaps if you unite the three of those together, it really does give you a sense of the market potential. If we look at the importance of IoT within the computing continuum, we asked our respondents across all of the domains where they thought the IoT fitted into their overall strategy. So the interesting thing here is that for agriculture, it is very strategic. So anyone within the field or the domain of agriculture, it's enabling new change. It's enabling the development of new products and services. If we look at manufacturing, it is much more about price sensitivity. It's about optimizing processes. It's about operational efficiency. So when you're looking at your customers and you're looking at deploying systems and really helping them get to that next level in their business, you probably also want to understand the role of your work. Where is it contributing to their overall positioning in the market, and what are their end objectives? Another piece of work that we did was precisely with those end users. So we asked them to assess, or we asked them to fill in a questionnaire to assess their cloud-to-edge IoT readiness. And it's a fairly simple questionnaire, no more than 10, 15 minutes to complete. And we asked them to really consider a range of different options in relation to their financial readiness, their technological readiness, their organizational readiness. So you can see them all here: industry and market, technology, risk and compliance as well. And the purpose was to help developers of new IoT cloud-to-edge solutions really be able to provide all the support that they needed to make sure their clients were making the most of these solutions. So the insights from that particular tool is that higher CI readiness tends to lower downtime and outages. And also we found that firms with higher levels of certification, and I think that one So those firms that do have certain certification tended to be also more cloud-to-edge IoT ready. There was also a correlation between investment in R&D and the ability to adopt cloud-to-edge. And one of the things that was really interesting was the link between organizations wanting to scale and that transition to much more complex systems. So these new meta-operating architectures are actually a blueprint for scaling. It's no longer about that system level, that sensorization. It is about making sure that all of those components, and I think it was Thomas, but also Yannick, who have really made or stressed the importance of partnerships in this, which is one of the reasons that we're all here today. It's unlikely that every or a single organization will be able to offer all of the capabilities that are required for a meta operating system to enable fast scaling, but by enabling those partnerships, well, by delivering with trusted partners, then that reality is much, much closer. So I think that I did actually have a couple of other slides here that were, but I think that we've got the wrong presentation up, but that's fine. But the other insights that we found is, for example, that there are two different acts within the European environment that are going to really affect future cloud-to-edge systems. One is the AI Act, which actually places some obligations on any deployer of systems. So you will have to, if you are deploying anything that is collecting data and analyzing that data and basically providing feedback on that, then there'll be certain obligations there. There will be a voluntary code of conduct, but if your systems are considered to be high risk, then the obligations are going to be much, much stricter. You're going to have to provide transparency. There'll be a black box requirement. So just something for those of you that are operating within more complex environments to also take into account. The second piece of legislation is the Data Act. So there's an obligation now on any supplier of systems to have to return the data that they're collecting if their client actually asks for that. And that is something that the Commission really wants to enforce to avoid hyperscalers or single, multinational, all-pervasive companies capturing the market and keeping that kind of legacy contact and legacy interaction with their end clients. So anyone can now ask for their data to be returned, and as long as it's something that's practicable to do that, then you will have to return that data to your clients. I think the final point I want to make relates back to piloting. So piloting of IoT systems is really important, but the piloting will only take you so far. Anyone involved in pilots should, at the point of the pilot, also be addressing the go-to-market strategy for that pilot. And that's something that shouldn't be done at the end of the process. It should be part of the design. So when you're looking at that initial blueprint for what's going to be done and what components you need, whether they're IoT or others, then the go-to-market needs to understand how that can be scaled across multiple systems, and sometimes systems that are operating in very, very heterogeneous environments. Okay. This is something that happens not just within manufacturing, but very definitely in transportation, where there are different needs, for example, when you go from across borders, and that level of compliance and understanding that scalability is going to be necessary at the design, at the phase of design. Otherwise, it's not going to go to market. And I think that the final thing to say about the IoT and cloud-to-edge continuum is that it's something that it's all pervasive. It's something that's going to continue to grow. The market is continuing to expand, and as artificial intelligence and large language models come into play, then the role of the sensors in collecting that data, the multimodal LLMs that we're going to be seeing come into operational environments are going to be absolutely critical. So for all of you here to understand how that particular technology is advancing and where you can plug into what are going to be called LMMs is going to be also critical, maybe not in the next 6 months, but definitely in the next 12, 24 months. So with that, thank you very much, and be very happy to share the slides with you if you need.
Awesome. Thank you very much, Tanya. Super insightful.